This is lesson 1-6, solve proportional relationships. And in this lesson, we will be able to solve proportional relationships. Okay, so uh, let's go back to our essential question. How can you show that two objects are proportional? This question we've been asking since lesson 1. And in this lesson, we'll learn two vocabulary words. The first word is proportion, which we will be defining in a second. And the second word is cross product. Okay, so proportion and cross product. And from our previous lessons, we defined what equivalent ratios are. So, and I took the liberty of writing it down, so to save us some time. So we know that two ratios are equivalent. Okay, so two ratios that have the same value are called equivalent ratios. Okay, so when you talk about the proportion, it is an equation, okay, with an equal sign. So whenever you see an equal sign, that indicates an equation. So an equation that two ratios or rates are equivalent. That's the reason why we have to define equivalent ratios to understand what a proportion is. Okay? So when you talk about the proportion again, okay, when you have two ratios or rates that are equivalent, that means they form a proportion. Remember also that a rate is just a ratio with different units. Okay, so the denominator is a different unit, the numerator will have a different unit. That's what makes a rate. So let's take a look at the real world link and see how this works. Katie and some friends want to buy fruit smoothies. They go to a health food store and that advertises a sale of 2 fruit smoothies for $5. So this is what we need to look at. 2 fruit smoothies for $5. Okay, so fill in the boxes to write the ratio that compares the cost to the number of fruit smoothies. Okay, so let's fill in those two boxes. We know that for $5, Katie can buy 2 smoothies. That is our rate. Okay, suppose Katie and her friends buy 6 smoothies. Complete the ratio that compares the cost to the number of fruit smoothies. Okay, so let's analyze this problem. So we know that for $5, Katie can buy 2 smoothies. So therefore, for $10, okay, Katie can buy 4 smoothies. And for $15, okay, Katie can buy 6 smoothies. So here, the missing number is 15. So for $15, Katie can buy 6 smoothies. Now the question is asking number 3, is the cost proportional to the number of fruit smoothies for 2 and 6 smoothies? So let's analyze the problem. Is the cost, okay, proportional to the number of fruit smoothies for 2 and 6 smoothies? Okay, so remember what it means to have a proportion. That means we will have two rates, okay, with the same value, or two rates that are equivalent to each other. Okay, so we have 5 halves, okay, and we're asking ourselves, is that equal to 15 over 6? So basically what I'm saying is that, will 5 over 2 be equal to 15 over 6? If they're equal to each other, therefore they are proportional. The cost is proportional to the number of fruit smoothies. Okay, we know that 5 halves, okay, if I want to convert this into a decimal, and I have 5 divided by 2, okay, 5 divided by 2, if you use your calculator, it will also give you 2.5. Now, if I get 15 over 6, okay, using a calculator, I get 15, divide that by 6, okay, I also get 2.5. Okay, since the ratios have the same value, Okay, so if you notice here, 2.5 is equal to 2.5. So since the ratios, okay, have the same value, since the ratios have the same value, the cost is proportional to the number of smoothies. Okay, so the answer here is a big yes. Okay, so let's go to the lesson proper. Let's go to the key concept, write and solve proportions. So now we had a taste, pardon the pun, about regarding proportions. Okay, so we use smoothies to give you that taste. Let's talk about the key concept, how to write and solve proportions. So let's take a look at the definition of what a proportion is. A proportion is an equation stating that two ratios or rates are equivalent. We know that from the beginning of the lesson. So what that simply means is that in numbers, this is what it means. If I have 6 over 8, it is the same as 3/4. Okay? So if you notice, I can reduce 6 over 8 to 3/4 by dividing this by 2, and I divide this by 2. Okay? So if I divide the numerator and denominator with the same number, okay, those two ratios or those two fractions are equal to each other. They have the same value, or in our case, they are proportional. Okay? So in algebra, algebra just simply means that instead of numbers, we are using letters. Okay? In algebra, when you have A over B equals C over D, okay, where B is not equal to 0 and D is not equal to 0, just giving you a restriction so that your denominator will not be equal to 0, and that will not make our number undefined. This is the main thing that we need to look at. So if A over B equals C over D, that means the two ratios are proportional. Okay, same thing here. If 6 over 8 is equal to 3 over 4, that means they are proportional. Okay, let's take a look at an example and see how this works. Let's consider the following. So you have A over B, okay, equals C over D. We know that forms a proportion because of our definition here. So that forms a proportion. Okay, so let's take a look at a little math here, and let's see how this works. So if you notice, okay, let's just take this down. So it'll be, if I multiply each side by BD and divide out common factors, so I multiply each side by BD, okay, basically what it's saying is that if I have A over B here equals C over D, and saying I multiply each side by BD, right there, which is what it's saying here, okay, and divide out the common factors, that means you can need to cancel out the common factors, okay, the B cancels out, that's what happens here, the B cancels out, and the D cancels out, okay, because they're both equal to 1. B over B is 1, D over D is also equal to 1. What happens now is that once you do that, you end up with AD is equal to BC if you simplify it. Remember, this means A times D is equal to B times C. Okay? Now, what does this tell us? Okay? So what this tells us is that the products, okay, AD and BC, which is this one and this one, are called cross products of this proportion. Okay, so the cross products of any proportion are equal. So what does that mean, cross products? Let's take a look at uh, this this illustration at the bottom right here. So if I have 6 over 8 and 3 over 4, remember that was our what's this? Our equation that was given in our definition of what a proportion is. 6 over 8 equals 3 over 4 right there. Okay, and we get the cross products, meaning we multiply 8 times 3, okay, and we multiply 6 times 4. That gives us 8 times 3 equals over 6 times 4. And if you notice, 8 times 3 and 6 times 4, they're both equal to 24. So if they're cross products of two, if the cross products of two ratios are equal, then that means those two ratios are proportional to each other. Let me give you another example. So if I have 1/4, 1/2, and let's say 2/4, if I get the cross products of this one, this is 2 times 2, and this is 1 times 4, and I see that this is 4 over 4, and they're equal to each other, that means 1/2, okay, and 2/4 form a proportion, okay? So these two form a proportion. That's what it's saying, okay? Let's take a look at example number 1. After 2 hours, the air temperature had risen 7 degrees Fahrenheit. Write and solve a proportion to find the amount of time it will take at this rate for the temperature to rise an additional 13 degrees Fahrenheit. Okay, so first and foremost, let's write, okay, sorry, not this one right here. Let's write a proportion where we let t represent the time in hours. Okay, now why are we uh, looking for t? Because let's look at the question. It says write and solve a proportion to find the amount of time it will take at this rate for the temperature to rise an additional 13 degrees Fahrenheit. So let's continue writing our proportion. Okay, write a proportion where t represents time in hours. Looking at the first sentence, it tells us after 2 hours, the air temperature had risen 7 degrees Fahrenheit. That is our first rate to our proportion. Okay, so in this case, we now have 7 over 2, where 7 is our numerator, 2 is our denominator, and 7 represents our temperature, and 2 represents our time. So when we set up our proportion, which means we have an equal sign, we have to do the same thing to our uh, rate, okay, on the right side. Meaning on the right side, the numerator should also be temperature, and the denominator should be uh, time. So where do we get that? If you look at the last sentence, it tells us write a proportion, okay, and solve to find the amount of time it will take at this rate for the temperature to rise an additional 13 degrees Fahrenheit. So we now have a temperature given, which is 13 degrees Fahrenheit, okay, but we now need to find the amount of time. So we have temperature, that 13 degrees should be on the numerator side, okay, and the time is what we need to find out, and that's exactly what happens here. So if you take a look at this one right here, we now have created our proportion 7 over 2 equals 13 over t. Okay, now we do our cross products. Remember our cross products, when we do our when we say cross products, we multiply 2 times 13, and then we multiply 7 times t. If we do that, this is what's going to come out. Okay, using cross product, the definition of cross products, we now have 7 times t equals 2 times 13. Again, 7 times t, 2 times 13. There you go. So 7 times t is 7t. 2 times 13 is 26. Okay, now for us to be able to solve for t, okay, we need to isolate t on one side of the equation. In this case, we need to use inverse operations. We need to undo, okay, multiplication. And for us to undo multiplication, we need to divide both sides by 7. So by dividing both sides by 7, we are able to isolate t to one side of the equation. Okay? So in this case, we divide both sides by 7. Okay? 7t over 7, or 7t divided by 7, 26 divided by 7. So time is approximately equal to 3.7. So it will take approximately, okay, 3.7 hours to rise an additional 13 degrees Fahrenheit. Okay, so going back to this problem, why are we dividing both sides by 7? Let me give you another example. Let's say I have 2 times x equals 6. So what will I multiply to, okay, to get 6? What will be the value of x so that I'll get 6? We know that the 2 times 3 equals 6. So the value of x is actually 3. Or what we can do to find the value of 3, we simply divide both sides by 2. When we divide both sides by 2, the 2 goes away. And if you notice, 6 over 2 is equal to 3. So now we find the value of 3. This same principle we are applying to this problem here. Okay? So do the guided problems and let's see if you understand example number 1. Let's take a look at example number 2. If the ratio of type O to non-type O donors at a blood drive was 37 to 43, how many donors with type O out of 300 donors? Now let's analyze this problem. We know that in this ratio that we started with, okay, we have 37 who are type O, then O, and 43 who are non-type O, so NO. Okay, how many donors would be type O out of 300 donors? If you analyze this problem out of 300 donors, the 300 donors actually represent both type O and non-type O blood donors. Okay, so it's not only non-type O, it's both O and non-type O blood donors. Okay, so what we need to do here is we need to write a proportion, okay, which represents the type O donors to the total number of donors. Because this represents out of 300 donors, this represents total donors. Okay, so we need to create a proportion, or we need to create a ratio first, where a ratio of the type O donors to the total number of donors. And this is how we do it. So now our type O donors is 37. And since our non-type donors is 43, we simply add it to 37 to get the total number of donors. So if you do that, we have a ratio now of 37 over 80. Okay? So after creating that ratio of type O donors to the total number of donors, we create a proportion. So now we need to write a proportion where T represents the total number of type O donors. Okay, so let's do this using our 37 over 80, okay, which is a total of type O donors to not total donors. Okay. We don't know the type O donors out of the 300 total donors in this problem right here. So this is how we have set up our proportion. Okay, 37 over 80 equals T over 300. Again, okay, take note of the fact that our numerator will be the type O donors, and on our denominator side will be the total number of donors. Okay, that's how you set up the proportion properly. So with doing our cross products, we multiply 80 times t, 37 times 300. And this is what comes out. Okay, it's smaller. So if you do that right there, 37 times 300. Okay, again, these two, and then 80 times t. 37 times 300 is 11,100, and 80 times t is just 80t. Again, using the principle that we learned in example number 1, to be able to find the value of t, we need to divide both sides by 80. Okay, so we divide both sides by 80. Okay, 11,100 over 80 and 80t over 80. The 80 will cancel out. You're only left with the value of t, which is equal to 138.5. Okay, 11,100 divided by 80 is 138.75. So the value of t is that there would be 139 approximately, because we round this to the nearest person, 139 type O donors. Okay, now the got it problem is very similar to example 2. Okay, and let's see if you get example number 2. Now in example number 3, we are going to use what we call unit rate. We've studied unit rate in the past. We actually did it in the first lesson. So you can also use the unit rate to write an equation expressing the relationship between two proportional quantities. Okay, again, if you don't remember, unit rate means that the denominator of a ratio is equal to 1. And for us to be able to find the unit rate, okay, again, let's recall that unit rate can be found by dividing the numerator by the denominator. Okay, that's how we find unit rate. So let's read through the example. Olivia bought 6 containers of yogurt for $7.68. Write an equation relating the cost C to the number of yogurts Y. Okay, how much would Olivia pay for yogurts at this same rate? So this gives us an idea on how to create our rate. Okay, so it says write an equation relating the cost C to the number of yogurts Y. So if we follow what it's saying on the sentence, on the second sentence, okay, first off, we need to find the unit rate, okay, between cost and the containers of yogurt. So following the second sentence, we actually create a ratio of cost C in dollars over containers of yogurt Y. So that means this is $7.68 over 6 containers. So again, to be able to find our unit rate, we simply divide the numerator by the denominator. So 7.68 divided by 6 will give us $1.28 per container. That is our unit rate. Okay, so what does that mean? That means that the cost, okay, is $1.28 times the number of containers of yogurt. So we know that our unit rate, okay, per container is $1.28. Okay, so for us to be able to find the cost, we simply have to multiply $1.28 times the number of containers of yogurt, and in this case, it's going to be 10. Okay, 10 yogurts. So we set up the equation. C is the cost. C represents the cost, and let Y represent the number of yogurts. So C equals $1.28 times Y. We know that Y is equal to 10 right here. So we simply substitute, okay, the Y with 10, or replace Y with 10. And then we multiply 1.28 times 10 will give us 12 $80. So the cost now for 10, okay, containers of yogurt is $12.80. Okay, so again, let's recap what we just did. First, we found the unit rate, okay, by dividing the numerator with the denominator. Okay, after finding the unit rate, we get that unit rate, okay, step number 2, and we multiply it by the number of containers of yogurt. So in this case, it's 10. And from there, we find the cost of the containers, of 10 containers of yogurt. Okay, so let's take a look at example number 4, okay, before we do the last got it problem. So in example number 4, it's JC bought 8 gallons of gas for 31, okay, dollars and 12 cents. Okay, write an equation relating the cost C to the number of gallons of gallons G of gas. So that means this again, okay, gives us a clue on how to set up our ratio. Okay, so how much would JC pay for 11 gallons at this same rate? So doing the same thing, okay, we need to uh, find the unit rate first, okay, and then after finding the unit rate, we simply need to multiply it by 11 gallons, or simply 11. Okay, so let's take a look at how this works. First, we need to find the unit rate between the cost, okay, and gallons. That's what we need to do, find the unit rate between the cost and gallons. Where will we get that? We'll get that from sentence number 1. 8 gallons of gas for $31.82. So if we do that, this is how it's going to come out. So the cost C in sentence number 2, okay, to the number of gallons of gas. So it's $31.12 over 8. And if we get $31.12, divide that by 8, you will get a unit rate of $3.89 per gallon. So we found our unit rate, which is $3.89 per gallon. Now what we need to do is we need to multiply that with the number of gallons. Just like in example number 3, we set up our equation, okay, where we represent C, okay, in this case, with the cost, and G with the total number of gallons. Okay, we don't know what the cost is yet, okay, but we know the number of gallons, which is 11 at this rate. So we get that number, we substitute that to G. Now we have 3.89 times 11, multiply 3.89 times 11, okay, we get 42.79, which means that the cost for 11 gallons of gas is $42.79. Okay? So again, this is another example that follows example number 3. Do the last got it and see if you understand both examples. Okay? And this is the end of our lesson. Thank you for watching.